You made this mess and left me with the pieces. Now I wanna burn all the bridges between us. I can't focus, I can't forget. I've been thinking too. You made this mess and I just need to clear my head. Now I wanna burn all the bridges between us. I just need to clear my head. I've been stuck on your memory, but it's not like I need it. And we may have some history, but we don't have to repeat it. You made this mess and left me with the pieces. Now I'm gonna burn all the bridges between us. I can't focus, I can't forget. I've been thinking too much lately. I just need to clear my head. 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 I just need to. I just need to clear my head. I just need to. I just need to clear my head. I just need to. I just need to clear my head. I just need to. I just need to clear my head. I can't focus, I can't forget. I've been thinking too much lately. I just need to clear my head. Oh, clear my head. I just need to clear my head. I just need to clear my head. Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this.
responsible. Preeti? Rushed from the office. Good.
Hello, sir. Good evening, sir.
Good evening. You are there. So I will share my slides for presentation, Siddharth. It is possible?
Sir,
Yes, sir, it is.
Okay. Shall I share now or shall I share after some time?
sir,
After
Yes, sir, we will have an introduction.
little interest.
Nikshita, you can start now.
Yeah, thank you, sir. Good evening, everyone. Good evening to all the dignitaries, guests, and delegates. I feel privileged to extend my warm welcome to everyone present here for the celebration of our annual technical fest, Cognitia. I'm extremely overwhelmed to get this opportunity to address you all. We all have assembled here to motivate and cherish the young minds. First of all, I welcome our eminent speaker guest, Dr. Debabrata Das sir, to share his knowledge and vast experience with students. Dr. Debabrata Das sir is serving as director of IIIT Bangalore. Sir has 3 US and Indian patents and 12 more are under review. Sir has received Professor K. Srinivasan Memorial Award 2017 for excellent teaching in the areas of telecommunication from IETE and many more awards like this. His main areas of research interest are IoT and wireless access networks, MAC, QoS, and power saving. So now I would kindly request Sir to share his valuable thoughts with us.
Thank you, Dasini, for your generous introduction. And thanks to Professor Harish Das for inviting me for this occasion. So nice of him for following up with me for a long time to give this presentation. And thanks to all the organizers of Cognitia and all of you for inviting me and also to listen. So I will share my slide. Then okay. So 1 second. Yes, it has come. It has disappeared. Now it has come. Are you able to see my slides?
Yes, sir.
Yes, sir,
Yes,
it
sir.
is visible
Yes,
now.
sir. Okay, great. I will not be able to see you because this has taken my full screen. So if you have any questions, anything, please stop me. Okay, feel free. And this is a topic on internet and 5G, which is very close to all of you and me and everyone on this earth, because most of us use internet. Who is not using internet? Any one of you there? I don't think so. So all of you use internet. But all of you must be eagerly waiting to use 5G because 3G and 4G phones are little slow now. 4G when it came, we were so happy, but later on we find so much call drops and it's pretty slow. But now we are all eagerly waiting for 5G. But due to the advent, means incoming of industry and IoT, Internet of Things, there will be a lot of change in the internet and also in the 5G. Myself, Debra Das, of course, you have introduced me. So let me go forward what I'm going to talk. So it is mostly a very high level philosophically when I talk about that what is the internet, which you know, but I will tell you that what is going to come into the internet very shortly within 5 to 10 years. These are very mind-boggling problems, and I have been working on this area for last 25 years plus. Sometimes, like a student, I started my life in this as a student in the hostels playing table tennis, and in the late night, 11 o'clock, and couple of friends used to have then ice cream. Of course, then after that, I used to ride my cycle to the labs, and till morning 3 a.m., 4 a.m. You used to work, and 4 a.m. come back and sleep. What you people are doing, I used to do that. And I used to enjoy that a lot. But now, with age, you have to move different directions. So I'll be, why I said all those things, because I learned a lot of fundamentals of internet when I was student, in courseworks and also the labs, that is still fresh in my mind, even though 25 years is gone. So what you are doing in the labs or in the class, please be attentive. If you, and these are very, very useful, those fundamentals in your whole life, even though you do research. So then comes, I'll introduce that, then I will tell you why computer networks, internet is so important. Challenges in front of us due to this Internet of Things. IoT means the sensors with internet connectivity, all kind of things called IoT. Network topology, access network, that is 5G, and why R&D is important for engineering and science students. R&D means research and development in the companies where you want to go for your jobs. You can ask me those questions. Also, I can give answers to those things if I know. So let me go to the introduction. Are you able to hear me?
Yes,
Yes, sir.
Yes,
Very
sir.
good. Because you looks like a very sincere people and calmly listening, but I am getting worried that whether I am connected or disconnected from internet. So for that only, I will asking you. Okay. So introduction. Look at this. So in the introduction, information technology, you people, all of you use information technology, because whether irrespective of any department, whether you are a civil engineer, mechanical engineer, electrical engineer, electronics engineer, computer science, IT, all of us use information technology, because the computer is in everybody's desk in the lab, or everybody's room who may have a laptop, or a mobile itself is a computer. So if I look at that, information in the broadly consists of what? This is, I mean, when I start my discussion with my students, I start from very fundamental. Where is the information is? The information technology we are talking, what is the information is? If you remember, we always say this information is consist of two digits, 1 and 0, which is given by a pulse signal, 1, and the flat one is 0, then again 1, again 0, like that. If you look at this information 1 and 0, they are only, for easy to remember, they are only in the 3 C states, only 3. Very interesting to remember. This is my, for my class to students to remember, I say this is, I call it 3C. Only 3 C's. If you look at the information, this 1 and 0 is one of these place. First one is, I always say, the conservation. That means the storage of information, the conservation of information or storage of information. So if you look at your memories of your mobile phone or laptop, PCs, or anything, any device, there is or your cloud where your Gmail is there, or so it is stored there in a database design, memories, different memories, RAM, hard disk, flash, cache. Memory management is a huge area, and memory itself is a huge area. If you're really surprised, I'll tell you, Intel was number 1 in the hardware and all till 2017. 2017, I was in sabbatical in Samsung R&D at that time. They were very happy. Suddenly I was walking. Suddenly I found a whole floor of R&D people who were happily clapping. Then I asked, what happened? Now we crossed Intel after 20 years. We are now the number 1 hardware company in the world, they said. Well, how? They explained, well, we sell a lot of memory, and memory has so much demand because of the storage of information. So our sale increased, so we became number 1. So they crossed Intel after 20 years, Samsung Semiconductor. So now they are number 1 or not, I don't know. I'm talking about 2017, they crossed somebody, okay? So like this, they celebrate. So conservation of storage is a big area, and your information 1 and 0 is there in the memory. Second one, when you kept in the memory, suddenly you activated a algorithm or a logic that is called computation. CPU, GPUs, where you pull these algorithms, machine learning, deep learning, all these things you are learning. You pull those information from the database and you do the computation. That means my 1 and 0s moved from the database and went to CPUs, GPUs for computation. So your 1 and 0 is either in storage or either in computation in your system. The third one is very equally important, is called communication. That means 1 and 0. Now I am speaking to you. This whatever I'm speaking, the voice and videos are converted to 100 and is going from here to you by communication, by 5G in wireless or terabits for seconds in a single fiber, and all those things are going to you. So if you look at the whole information, I can see they are only in these three C's. When conservation of information, computation means memory or GPU, CPU, or in communication mode. That means I am sending an email to you, it is flying and it reaches your system and it gets stored. So either it is on the way, on the flying in the wireless or optical networks, or in the computations. These three states, I don't see it is in any other states. These one and zeros are. If you have any questions, you can help me out. These are my class teaching creations. Okay, so to make the easy. So these are the three C's. Why I am saying this? I'll be stressing on the last one, the communication, internet and communications are the so important in this whole world. So because every one of us, mechanical, civil engineers, any business you do, health, everything transaction happens by communications. So if I look at all these three C's, for all the above three lots of R&D going on for better hardware and software to make the products. So anywhere you go, there are a lot of hardware and software required for conservation of information, computation also, those CPUs, GPUs and all, and communications also. Your transmitter, receivers, your base stations, mobiles, tablets are connected to that. So a lot of, so these three has hundreds of sub areas for research and development and product in information technology. Broad umbrella under the information technology, computer science is coming, electronics is coming, electrical engineering is coming. All the applications of the different civil, mechanical comes under that. So all these three areas of three C's has a lot of research going on. Having said that, let me focus on communication. I will give you a very interesting example in my next slide. If you can see why networking communication is so important. You know it. I don't have to tell that. I will touch all aspects of day-to-day life, which is written on that chart. Siddharth, my mouse is moving. Are you able to see that?
Yes, sir, it is moving.
Ah, very good. So you look at these examples of networks very carefully. See, if you see, there is something called communications. Communication is kind of telephones, internet, postals, TV, radio, pager, credit, LAN, WANs. Welcome. Transportations, highway systems. If you know or don't know, I don't know, nowadays buses, trucks, all are connected by these highway systems. If you have a truck fleet owner or a bus fleet owner, your all buses will have a GPS connection. Owner sits at the room and sees my bus is going from Shillong to, say, Guwahati, how far it has gone, it can see that. Okay. Air traffic systems, all the planes are connected, all the ships are connected in the Pacific oceans. Can you imagine how many ships or medium-sized boats are there only on Pacifics or in Atlantic oceans? Can you just guess? It will be in lakhs. Okay, so all are connected by the networks, by satellites. Social life, family, friends, and cities. Biological, neurological ecosystems, all are connected by centers. The moment your storage power, you are switching on light in your room off. Do you know the power grid is controlled by the computer networks? They give a command, connect from this grid to that grid. Command goes to the network. Then there is a transformer. There is all kind of things to connect you. Fresh water. So if you look at yourself, I'm telling you very jokingly. When sometimes in the class we are not allowed to take mobile. Are you allowed to carry mobile to your class and watch?
No, sir, we are allowed, but we need to switch it off.
Switch it off. Okay, very good. Good boys you are. But sometimes, yeah, don't tell anyone. Sometimes 1-2 boys will be sitting on the back and some students will be back. And sometimes they watch WhatsApp or some messages from their friends. So if I see what I do, I simply go close to them and take their mobile and put it in my pocket. Then after the class, I just walk out from the class, smiling face, and I go to registrar of the university and hand it over the mobile, telling that, please keep it. Then student will be following me, okay. Then he will be standing in front of the registrar's rooms, okay. Sir, दे दो phone. तो सर तो और भी रजिस्टर साहब तो और भी स्मार्ट है, तो डिफेंस से आए हैं, तो वो थोड़ा he will make you people to little 1 hour, 2 hours, and then he gives it. So what we learn, you see, what I want to say you is this. This is a very beautiful study I did. I studied my friends, which when I was also a student, I was also like that, but I didn't have a mobile at that time, 25 years back. So, but so what people come to the class morning sharp in the time class. Half of the students don't take breakfast, and they come to the class and they don't mind coming like that and attending the classes. They straight away go to the lunch or something like that because they work out at 3-4 a.m. and they sleep, and then they go to the class at 9 a.m. half hungry. But they don't mind. But if you do not give, if you LAN is down for a 1 minute or 2 minutes, there will be a lot of complaints. Sir, campus LAN is down, or my mobile is taken by the registrar. What does it mean? That means this, you being a student, let me tell you, you are the least user of the mobile or networks. Let me tell you very frankly, because when you do the jobs, you will be, network will be your, like your bread and butter, because your whole business is running, all your job, companies, work, all around the network. So that means that being a student who is not any commercial use of the network, but you are so dependent, you are not going away from the mobile or campus network from your LAN for 1 minute or 2 minutes. If it goes down, you mind. So what I wanted to say is that by this using the network for your day-to-day activities, you are so much dependent. If somebody takes away the LAN or internet connection or your mobile connection from you, then you feel suffocated. Hey, something is missing. Hey, I am not able to see my message. Hey, I'm not able to connect and send my mails or upload my assignments. Hey, I'm not able to go to the LMS, my learning management system, and download my studies. So you feel suffocated. Suffocation happens when you don't have oxygen. So the network is now my second oxygen. Looks like, I have written it here very carefully, looks like important after the oxygen. I call it second oxygen. Just the thing which I said to you, you just ask yourself, if somebody takes away your mobile, how unrest you become. Very, very worried. Hey, मेरा mobile ले गया, वो दे नहीं रहा है, 1 घंटा से games खेल रहा है. So you feel yourself very unrest. So that means you are getting addicted to the networks, like oxygen. Oxygen smoothly going and coming in, but you have read in the COVID wave 2 what oxygen called the havoc. Without what is the importance of oxygen, you understood. So it is smoothly going in, coming out. But if the oxygen will go out, we will feel suffocated. It is a life and death. Similarly, network is like that to us now. We feel as if something is going away. So it is that kind of importance creating in our life. It's like a second oxygen. I personally feel to my students. My students, if I can disconnect the LAN or I disconnect the mobile, they feel like that. But they don't mind or complain why the breakfast was not available. So that is the beauty of the network, dependencies. So having said that, so what is going to happen? So Industry 4.0. So I am trying to create some interesting points that slowly, because you see, you are so much getting dependence on the network. In my previous slide, I said all this you can't imagine, whether you are sleeping, whether you are awake, whether you are walking, everything is watched by the network now. I am working on some of the top projects of this country, where if you after a few years, if you leave Shillong and walking down in Delhi, I can tell you are here. So world has become ever more digitally and globally connected with every industry embracing ICTs. So this Industry 4.0 revolution, which is going on now, it has a manufacturing impact, smart factory with IoTs, so robots and all. Healthcare, healthcare is present is so many sensors connected to the patient and is connected to the networks. Media, entertainment, every day you watch movies and all. Financial, this you know this. Now we are all surviving due to online food and online groceries at home, or a banking transaction, public safety. This is I was talking about. I'm working on this on a big project called Safe City for the safety of the women, children, and any person. So automotive autonomous driving, cars, office on move, practically, you name it, transports, everything, energy, education, of course, education online, who understand better than you. So now, there are hundreds of bullets I can do, like this, hundreds. Agriculture, water management, sewage management, everything now is controlled by this digital world. But what will be its impact? Let me tell you. Because here I told you only the glimpse of it, but now this one comes in. What will be its impact? I'll tell you. So this is industry 1.0. Industry 2.0 is called electrification, mechanization, electrification. When the gear came, electricity came, digitization came in 3.0. Industry 4 now is connectivity, and industry 4.0 plus 5G will give us wireless connectivity to all those robots, driverless cars, and all kind of things. So don't think that it is only I am talking to you with respect to technology. It has a $5 trillion of economy, which is a complete going to be India's GDP is only 3.5 trillion now, or 3 trillion now, whole India's input. But look at only this one, this four evolutions of the industry will give me 5 trillion, complete country's income, more than that now, after India is aiming for 5 trillion. Out of that, manufacturing in the worldwide. So can you imagine so much jobs will be there in IoT or connected to the internet? So you can see container ports, oil refineries, manufacturing, constructions, mines, warehouse, wind farms, oil rigs, anywhere. One professor used to work, he still is very close when working with me until last year, very closely, worked 4 years for a project. That professor from Netherlands used to deep dive into these oil rigs below around 2,000 meters. He's a deep diver, actually. He's himself a great professor, very renowned. He goes and puts sensors there for the finding out those oil pipes, containers, what is going on. Transports, constructions, utilities, mining, everywhere. So very good questions may come to your mind that, hey, then how many IoT devices will be connected? SAR showed me so many things. How many connected to these networks? A tentative estimation. So I was teaching a class IoT 2 years, 3 years back. Sometimes suddenly one student asked me, one from industry, he works in R&D, hardcore R&D, he was there. He asked me, sir, how many IoT devices will be there in this world? I told him it's me around 10, 20 billion in the plan, I said. Billions is a big number. For us, we are all conservative very much because we are from academia. But sir, wait, let me go to the board and explain you. Then we started calculating. Okay, look at the fun of Maya and my students. So he said total mobile is 4.5 billion in your hand, in your pocket. If I look at whole world has a 4.5 billion mobiles. Laptop 1.5 billion and tablets 1 billion, total 7 billion connected to the Wi-Fi or WiMAX, your base stations. Due to smart city, home, car, agriculture, all smart cities, smart homes, smart cars, smart agriculture, smart health, data. So everywhere people put smart. Average 100 IoT, Internet of Things devices per person. He then tell me how the calculator say urban cities, you have 150 per person, rural say 50. So 150, how a person may have a multiple cars, a big home, and also more sensors in these, so 150, and rural is a 50, so 150 plus 50 by 2. Rural plus urban 112, so 100, he told me. Very simple way. He said, assume world population is 7 billion. The total IoT devices will be connected. 7 billion into 100 IoTs is 700 billion. Look, 7 billion now with all this mobile connected to your networks, and it will be 700 billion within down the line 10 years or 15 years, I assume, which I showed you in the last slide. So many manufacturing all are coming in. So equation A is 7 billion, equation B is 700 billion. So in next 10 to 15 years, 1% means 7 billion versus 700 billion will be human. Human will be only 1% on the network. 99% will be machine connected to the network, machine to machine communications. Did you understand? IoT will be doing the all kind of things from sensing, sending the data to another machine in your cloud or edge computing or cloud, where there will be no human intervention, and that cloud getting the data will take a decision and command it, like artificial intelligence or machine learning. So now we think that it's mobile, we in our hand or laptop in connected to the network, we think that we are the maximum user of the network. Absolutely not after 10 years. After 10 years, 10 to 15 years, we, the human being, will be 1% or less than 1%, but 99% plus will be the machine connected to the networks. Got it? So these are the dynamics change going to happen. Let us assume, I always jokingly made it 700 billion plus 7 billion. So I make it like a Boeing 707 billions connected to the network, 707 billions devices connected to the networks. What will happen? With 7 billion devices, mobile laptops, so many call drops, quality of experience is bad for voice and video. Every day when I come from the office, most of the days I call my father from my office. So on the way, it drops 3 times. I'm staying in a Bangalore kind of city. I'm connected to one of the reputed network. I'll not tell the name of the network. So it's not fair for me to telling that networks. And 3 times it drops on the way. And I again reconnect and talk to him. So that these are the feeling in my all of us feel. And quality of experience is not so good in 7 billion. So if when 100 times more devices will be connected to the same internet or through the wireless networks, and 707 billions down the line 10 years, what will happen to our quality of experience? Have you ever thought of? These are the critical problem to be solved, yet to be solved. Each IoT device has different requirements. For an example, if I am driving a driverless car, I need a 1 millisecond delay, and my temperature transmission of a room, and another kind of IoT device, which is maybe 1,000 millisecond delay. So 1 millisecond, 1,000 milliseconds, same infrastructure has to give me, same network has to give me one kind of devices like driverless car 1 millisecond, another device only temperature 1,000 milliseconds. So same network, I am expecting both kind of things. We need network to support above kind of differences, how to do in same network infrastructure. This is a huge, huge challenge over the internet or 5G now. It's a huge research. Then came the network topology. Let me quickly make you understand. Are you able to hear me?
Yes, sir.
Yes,
You are
sir.
audible.
Yes, sir.
Yes, sir.
Are you able to understood the problem here?
Yes, sir.
Yes, sir.
Okay, some extent. Okay, fine. Thank you. So what I wanted to say is that with 7 billion, this is the problem. If 707 kind of number of devices get connected to the same network, what will happen to us? We will not get any connections or not good quality. But we have to do the research and solve that problem. So it will be solved, don't worry. So network topology, if I look at this. This is user equipment. This is your mobile or IoT devices, or this was a satellite networks connected to the satellite, or this is a laptop or a phone connected by ADSL connections. And this is the LAN, this is optical fiber. They're all connected to the IP backbone. And global internet. And this is called user equipments here. And this is called access networks. And this is called core network. And this is called service network. What is service network? It is called your cloud. Inside that, all applications are connected. So there are so many networks there. User equipment get access to a network called access network. And core network is the backbone. You are sitting at Shillong and you are calling your parent in Delhi or in Bhubaneswar, or you in Bangalore. So this crosses from Shillong to goes to the backbone dish to Bangalore. I'll show you the next network. Or we are writing an email and saving in the cloud of the Google Gmail here. So this crosses core network or backbone or international backbone like this and reaches to the cloud. So I'll be talking about the access network more, but before that, I'll show you the core network, how the backbone looks like. And you are here. This is 700 billion and this is 7 billion devices. Look at this. This was designed by us in 2013, 2014 for the country. This is the backbone network service provider in India. So if you look at, did you have a NCAN, National Knowledge Network, in your campus? NCAN we called it. It is there in your campus. It may be any professor you can ask. They may be knowing who is in the computer center. Government of India has given to all the NITs, IITs, IIITs, NCAN connections. This is NCAN connections, one of the connections networks. So this is the Guwahati, Delhi, Mumbai, Bangalore, Chennai, Hyderabad, Kolkata. These are the 7 super nodes are there. And from Guwahati, it has gone to Shillong. Okay, like another state 4, this may be from here Guwahati, it is connected to your Shillong, and a state 8, then it is connected to your campus, say NIT here. And you are sitting at NIT Meghalaya or Shillong, and you are writing a mail to your friend sitting in, or friend or relative in the west coast of United States. So how it will come? Look at my hand. You are sitting at here. It will come to your Shillong router. From there, it will come to Guwahati. From Guwahati, it will go straight to the Mumbai, then under the sea. This is the map. Under the sea, look at this map. This is the Mumbai, India's Mumbai. You came from here, Shillong, to the Guwahati, to the Mumbai. Under the sea, you are moving from here, here. And now you will go to UK, then you come to New York, and then New York, there is a Long Island near to that, it comes out, and there is a fiber connected to this side. To say he's in California, I'm just giving a long distance one. Or from Shillong, you come out, go to the Guwahati, this picture I showed you, Guwahati, then you can come to Chennai. Where is Chennai? Here, Guwahati to Chennai, and you come to Chennai is here. You see India map is here, Chennai. Under the sea, go to the Singapore. Under the sea, you go like this. You come out from the other side of the sea, Pacific Ocean. Here is the California. So 2 ways you can go. You can go from this side to here to California or this. This United States has this network by AT&T. So it will reach to New York, Long Island, then it will reach to the Californias, here, San Francisco. Just even giving an example. So you have crossed close to 14,000 kilometers. When you are doing you are making www.apple.com to see the Apple products, or you're doing some Google headquarters, what is going on, internship is there or not. You are traveling from here, from here, Shillong to Guwahati, and going like this, 14,000 kilometers. I said you so simple way, 14,000 kilometers, showing these all networks. But have you ever imagined that I just wrote www.apple.com, I want on my screen within the few seconds. 1 second is equal to 1,000 milliseconds. Why it is not coming? If it is coming, then why it is slow? So these are the things you must have studied in your some undergraduate courses called Computer Networks 101. But I wanted to take you a little deep dive into it. So look at this. You are sitting at a 4G network on your mobile connected to the base station, and this base station is connected to a Shillong networks. This is your metro networks, and it is connected to the national backbone. Core national backbone is this one. So which is nothing but this one. This is your national backbone, India's backbone. And this is my international backbone under the sea. And this is US backbones. Like this, you reach the destination. So look at the fun. So delay calculation of propagation only. But what I wanted to show you is that if you look at this, if your computer, you are crossing like this, inter-autonomous system, and this is the national backbones, like this, you move every routers and reach the destination. Just a pictorial view. Every router has this, each hop has queuing delay, processing delay, transmission delay, and propagation delay. What is queuing delay? When your packet is coming in front of you, say Siddharth is sending a packet, in front of him, the Ashin's packet will be there. So you have to stand on the queue. After the Ashin packet is gone out, then his packet will come in and processing. Processing means protocols. Your application which you opened up, the application protocol, then the transport layer protocol, the network layer protocol, all set up protocol. After your every protocol's action is done, then the transmission will be done to the next hop from here to here. Then transmission. While transmission, there is a bit rate. In your system, you must have seen I am transmitting in 100 megabits per second. That is a bit rate. So if I transmit 1 megabit file, if my transmission speed is 1 megabit per second, my delay is 1 second, only transmission delay. Then propagation, inside the fiber, how much time I took. So if I look at that, if I calculate for a fiber, it is a 5 microsecond per kilometer. So if I want to go for one way from here, from my Shillong to the California, my 14,000 kilometers means one way I am taking 70 milliseconds. Only propagations. I am not calculating queuing, processing, transmission. Particularly queuing and processing takes a lot of time. But I am expecting that everything should happen in a 1 second and 2 second. The moment I write www.apple.com, it should be in front of my screen. So EV from Bangalore to Aadhaar in Delhi, it only one way from Bangalore to Delhi is 2000 kilometers, so 10 milliseconds. Only propagation part I am saying. But if I add up all delays in every hop, it will be multiple seconds. So my system is so slow because protocols are slow, processing is slow. So having said that, what is expected from the access network infrastructure for the next 5 years is very, very important. So what is expected? So what I said you here is that why delay happens from here to here. Here I am going to show you some of the expectations. So what has happened in the 5G, they have broken down all the applications in the mobile that IoTs, which is coming in. I told you, 99% will be machine-to-machine communication. I showed you the example. So they are saying they will be under these three categories: enhanced mobile broadband, or massive machine type communication, MMTC, or EMBB, enhanced mobile broadband, or massive machine type communication, or massive IoT communication. Critical communication, ultra reliable, low latency communication. If you look at all the applications now coming under the 5G falls into these three categories. Ultra reliable, low latency means ultra reliable means driverless car. You are going to office and sitting at here. If you after your graduation, many of you will come to Bangalore and you will be going to office. And you are a driverless car, you are sitting on the behind and reading newspaper, or you are working on your laptop, and the car is going, driverless car, okay? And Bangalore, maybe, I don't know, but if you come here, horrible traffic. Anybody can come from any direction, right to left, left to right, somebody may jump from the tree on you also, I jokingly say that. And from a manhole, anybody come from the bottom to suddenly come out from manholes and tell you, hey, I am here. So you have to push the brake. And if it's a driverless car, don't react within a 1 second or 2 seconds, then the person will be in the ninth cloud. You understood ninth cloud, okay? So this kind of communication has to happen in a very, very fast way. I'm just joking and smiling, but you can't imagine. We have in the lab sleepless night across the world, not only we, across the world, to meet the requirement of ultra reliable and low latency, because wireless has a lot of losses of information. If you talk on your phone, you can understand how much time you can clearly hear your voice, your parents' voice or not. So having said that, this is the driverless car infrastructure, like only 2 milliseconds. Tactical communications like remote surgery, 10 milliseconds. Video games, 50 milliseconds. But now you have reached up to 150 milliseconds. So voice, your 4G phone, if you're using 150 milliseconds. So if I say hello from here, it should reach you within 150 milliseconds. But I want to bring down from 150 to 2 milliseconds over the same infrastructure to meet ultra reliable low latency. How to do that? And there are some non-real-time traffic like temperature, humidity, I'm transmitting it 1000 millisecond, 2000. So look at the difference from 1-2 millisecond to 1000 millisecond over the same infrastructure. The utter difference we cannot have satisfied for presently on the present situation. So now look at how an information moves from source to destination. If you have not gone through this computer networks, let me tell you, in your all system, if you just pick up your mobile and just open your WhatsApp, that's called an application. And according to IETF standard, there's 5 layers that are in your own mobile or own laptop. So top one is called application, then come transport layer, network layer, link layer, physical. Each layer does a different functions. Application looks after your application and presentation and session. Transport layer is reliability of information or unreliable kind of things. Network does the routing, and link layer does the when shall I transmit. What is very interesting, you people might not have noticed this, or might have noticed. I'll tell you link layer, what is data link layer does. Very interesting. You 5 people sitting on a laptop working on an access point in your hostel, and your assignment is there. You are constantly uploading and downloading. But while uploading, look, all of you connected to the same access point with the same frequency. That means if you and 2 people transmit at the same time to the access point, you will get collided. But my point, but your laptop is a machine and your friend's laptop is another machine, but they're so intelligent, they don't collide. High probability is that they will not collide. So those intelligent protocols are in data link layer, this link layer, but means I will not collide. Data transfer between the neighboring networks elements. So these are the things makes these 5 layers, and the physical layer makes your transmissions. So these are the headers we add in those things. But if you look at this, how it looks. I started transmitting, you see, very carefully, you see. Again, I will go. I will start from applications that it crosses each layer, but each layer has a function toward. The software makes slow. These are all software layers, except physical layer, other layers, and data link layer is a 50-50, hardware plus software, but other layers are software, very slow. So I see process, physical layer transmitted, again, then it reaches the destination. And on the screen, you can see it here. And I've just shown you with one router. If I have hundreds of routers to reach the destination, 100 times I have to do between the routers like this to reach the destination. So I slowed it down. And everywhere there is a queuing delay, processing delay, and transmission delay and propagation delay. So it's a time consuming. So you please to understand physically, system-wise, this picture is very, very important. At the sender side, it went start from the top. But at the receiving side, it will enter from the bottom. Look at this, and it will going up. So this is the interesting part. So it's happening everywhere. So having said that, so I have to reduce delay everywhere to attend this 2 millisecond or 1 millisecond of my concepts. So the 5G needs to be flexible, accommodate diverse cases and all. Main requirement of the 5G, which I have already said, you enhance mobile broadband, massive machine type communications, ultra level low latencies, all over bullets supports IoTs, all over everywhere Internet of Things is there. I've already talked to you that Aadhaar, maybe 300 milliseconds. The Aadhaar is a high, more delay than the driverless car. Driverless car maybe 2 milliseconds. Remote surgery is 10 milliseconds, like that. A lot of robotic surgery is going on, and single packet failure here, single packet, there will be accident or there will be a cut in the body unnecessarily. So where is the change for the previous slides requirement? If my same infrastructure, I am connected by the 5G network, and for driverless car, I am asking 2 milliseconds, and here I am 300 milliseconds, how to achieve from the very, and provide the requirements for the same infrastructure. Are you able to listen to me?
Yes, sir.
Yes, sir. Okay, very good. So now quickly, I will tell you, look at this. If you somebody transport layer, which I showed you, has only 2 protocol, TCP and UDP and congestion control protocol 1. If your laptop, in your laptop, you're using mobile, if you're in your operating system, there is a one part of operating system, a lot of files are there. If you just open Linux operating systems or any operating system. So one part takes care of the your network part. So these layers, this transport layer, network layer is there in your operating system. And data link layer and physical layer, they are in your NIC card, network interface card, which is there in your system. Okay. So now, so this bottom 2 layer is done by 3GPP or 5G, which you are using now, or IEEE. If you are using Wi-Fi, IEEE standard, then bottom 2 layer is configured to that. When you switch over to Wi-Fi, IEEE 802.11 get activated. When you switch over from same mobile to the 4G from Wi-Fi, this 3GPP, 4G or 3G or get activated. And top layers are standardized by IETF, Internet Engineering Task Force. But what has happened, they have only 2 protocols in transport layer, network layer. One of them you have to choose, OSPF or BGP, Border Gateway Protocol, open shortest path first, which only 2, and here also 2. But look at this, I have so many applications, hundreds of applications where my delay is 1 millisecond, a few millisecond, 2 milliseconds, thousands of milliseconds. Okay. So only for so many applications, I have only 2 options, no, not more than that. So as a result of which, this existing architecture is not going to solve my problem. People are doing a lot of research to solve these critical problems now. So direction in the 5G is like that. So worldwide, various standard bodies are working on 5G systems. Where is the 5G? The access network, the last mile. You know that the base stations to you is called, will be, instead of now it is 4G or 3G, it will be converted to 5G down the line 3-4 years. Our industry and academia agreed on 2 following complementary views. One, evolutionary view, other one is called service-oriented. Evolutionary view is saying you evolve natural transition from 4G to 4.5G to 5G, evolution. Don't throw away what is existing. You invent on the top of that and make it faster. But service-oriented view says just throw away whatever is there. Design from the scratch, and it requires some same physical infrastructure network to take different forms depending on the service requirement. Naturally, to the notion of network slicing. It's a new concept coming in. You might have heard. I don't know. I'll show you the pictures. Called network slicing is a service-oriented view required for radical rethinking of existing mobile and backbone network. You'll be using that. People are working day and night on this. Some of our labs are in India also working a lot. Some are in IIIT Bangalore also. Some of my students are working also. We are learning a lot, publishing already from last 2-3 years. So this is a new concept. I'll show you. It is like this. So same infrastructure. If you look at number of base stations 1, 2, 3, 4, 5, the routers behind it 4, all these pictures are same. So if I am using this same infrastructure, RAT stands for radio access technology, maybe 3G, 1 radio access technology, RAT1, and 5G, RAT2, 2 radio access technology. This is a 5G slice 1, which is used for only for the mobile phones. So when I switch on a mobile phone, this first slice over the same infrastructure will give me, what is this slice stands for? They will give me certain amount of spectrums, and the resources in these routers and the base stations will be allocated to me according to my mobile phone requirement, which is a voice call or a video call with you. But if I'm using a driverless car and connected to the same 5G, I will have a different slice. Means I need a ultra reliable low latency with a very low delay of 2 milliseconds. So another part of the resources, more resources will be given to you. For an example, if you are in a laptop, you are doing some simulation or doing some computation, you will find your CPU is more used for the computation works at 30% or 40% is there, and maybe 5% used for the browsing. So if the demand is of the computation is more, the CPU is given more. So these slice will be giving more resources from this network to this driverless car. So the same infrastructure will be giving the different slice of resources for using. So this is called network slice. Understood? So you see IoTs, different IoTs, same RAT1, RAT2 is giving different slice. So this is called slices. Okay. So these are the new, it's coming up in a big way. So how it will be done? These are called software-defined network controllers, SDNs, and you are here. You are calling to your friend at here, from left to right. And I want to do a video conference with my friend from here. So the moment connection, I dial, you remember you dial, you put the friend, so it will go from here to the control packet to the here. The control packet find, oh, this is a video call. Now he will give a command to all these switches or routers, hey, give him 1 Mbps bandwidth constant from here to here for next till he talks. So then the switches will allocate the CPUs or GPUs or the memories or the bandwidth according to here from wireless to destinations. Right. So like this, you get the ringtone after this. Then if he picks up, bandwidth is booked, and then you come and continuously talk without any problem. And these are all packets. So this is a very complex because there are a lot of different applications with respect to that. So having said that, let me quickly move on to some of the extra tips I was just thinking to give you as a student, what you should do in your life because of so many interesting areas. Every area is very interesting. I am talking to you about the internet because all of you talked about internet or 5G, 4G. So I talked about that with a very high level of glimpses because this is not a technical conference or technical talk. So, but it's a broad talk to take you that from scratch. What is the IoT? How many numbers IoT will come in? How my backbone looks like to what is happening. So I let me go quickly. So what is your oxygen 2? I said you oxygen 1 and oxygen 2, how the network, we are getting addicted to the network, then IoT, then I showed you the IoT business, then I showed you how many IoTs will be there, 707 billions total will be on the network. Then what will happen to network? Then I showed you the topology. Here is the 5G network, say, in future. So access networks, then this is India's backbone, which you are using in your campus. So this is your international backbone. This is US, for an example, and all kind of things. What is the delay, and what is the expectations from the next generation of network from 2 millisecond or 1 millisecond to thousands of milliseconds expectations. And now I showed you how a packet moves in this picture. Then I talked about this. So what is the problem? Bottleneck is here, main bottleneck. So now, do you have any questions, or you will ask in the end? I'll take another 5 minutes quickly to finish this is the future of your networks, which is going to be used in your SDN software-defined networks. Okay, a lot of jobs are there in SDN 5G now. some extra tips in the for the students. So why product company? Why? You see, in India, if you look at from my areas, when I talk about, there are two types of company. One is called service companies and one called product company. Service companies means if somebody has a product, I go and give services to that. That is called service company. So why a product company is important? Because product means, look at your mobile. This is a product. Look at your laptop. It's a product. I'm giving this to example because every one of us use that, or a PC, a product. Customer, people, government department keep asking value addition to any product. For an example, you ask yourself, if you have a mobile now and every 6 months there's a new version is coming, like Samsung's, Apple, and any of these editions, if you look at every six months new version is coming, and every edition has a 30% new value addition. Memory is more, speed is more, camera density is more. So if you look at every product company has, any product comes out, it has more value additions. 30% new value addition. Any value addition means the memory smaller and more powerful, or a computation is more powerful, means any value addition needs innovation. New value addition will give up premium of cost and satisfaction. Okay. I feel the people in product company are lucky. Why? Because if you do a value addition, means innovation, means the brain is used for new innovation and development of own creations. That's very important. So every time, if you're service industry, generally we code what others have invented. But here you invent, and if you're in R&D, then invent and also code or make hardware design or anything, any product like a car design or a civil engineers, if they're structural design, is innovations, new buildings. Hence, with new technical innovation in products and aggressive marketing and sales makes us to survive our jobs. So there is a technical people and there is a marketing sales people. This combination, if it's good in a company, look at all the companies give so much advertisement. Then we come to know about the product betterment, value addition. Then we buy. When we buy new phones, you see the old phones versions are 30,000 or 15,000. The new versions will be 75,000 and 1 lakh. That 1 lakh, if the previous version and now there is a difference of 50,000 to 60,000. Why? Because of new value additions. So for that only these companies are so rich. The above story is true in any good companies. So if you want to go to do a job, you want to be always agile for your lifetime, go to any product company. Product company, I am not saying only that IT. I am talking about any of your areas of interest. For that, you have to study in depth and go to the depth. And I will give you an example at here quickly. If you look at why R&D, why research development equally important for a product companies to survive. Example one, you might be heard a name called Kodak company or not, I don't know. There's a real company there for cameras. And it was a very rich company because it was a complete monopoly across the globe for selling. But they invented digital camera, but they felt that, hey, it will not be used. Let me throw it out and let others use it. And they dependent on that real waste. But when the digital camera came in and became very successful, this company got disappeared. It was completely set back. So do not sit quiet in a happier time. That is the story. When Kodak became very happy with a lot of money, profit. When their great days, they didn't talk about that world is moving. Second example I am giving with all respect to all the companies, I have nothing to do. See, Microsoft, Oracle, and here TCS, Infosys, Wipro, you know. So if you look at, this is a product company and this is a service company. Service means if there is an IT software to be developed or IT software, they don't invent majorly. Nowadays they have invention centers, they have lab, research labs and all, but majorly they do a service. Means any company like Infosys call them, or sorry, Microsoft calls them, Oracle calls them, or SAP Labs calls them, hey, can you come, Infosys 100 guys, can you do this? I have invented this, can you code it for me? And then they go and code it and maintain it, then they maintain it service. So why I'm showing this is because all these 5 companies almost born in the same year, almost maybe 1-2 years plus minus. But now if you look at the Microsoft and Oracle, due to the profit and due to the product, they may be at least maybe 5-10 times more larger revenue than the TCS, Infosys and Wipros. Maybe, I'm not, maybe 5 to 10 times. Why? Because product has more profit and product has more. So for the salaries of these companies are generally much higher than the service industries. Generally, I'm not saying always. In-house research development means every company does in-house research and development. At least core part of the product in the organization keep in IPO, that is company strength. Any company, because I have been working very closely, used to work on two top MNCs in two different areas for last many years. So now I left it because of my new role. So I have seen they keep the intellectual property right very close to their heart. So you should work on these kind of things. Participate in standards. You may not be knowing in industry. When I was as a student, nobody talked to me about standard, but let me tell you, I talked to my students. So any research leads to a standard. After the standard, the products are done. So if you want to sell any product like your phones or your base stations, your laptops, for a simple example, look at the USB. USB is standardized, exact width, exact height, exact number of pins. If it is not there, if the USBs will be produced by different standard, it will not compatible to you. So it is being standardized. Look at the electric plug. Look at your mobile phone. Mobile phone transmission receivers is standardized, so your base station able to catch your signal. If required, collaborate according to your requirements. My learning in Indian system is that in all conditions, never give up and be positive. In Indian condition, you never give up. There will be a lot of challenges. The moment you do any good work, there will be a challenge. Don't hesitate to face it, but never give up. Be positive, be sincere, be hardworking. I can give you and guarantee that you will be definitely successful in life. No one can stop you. If your attitude is good, your integrity is good, these two are the very important. First, point number one, I am not talking about academics. I'm talking about your attitude and integrity is number one. Number two is your health. Number three is your academics and innovation. So according to me, those two are the more priority. And thank you very, very much for giving me an opportunity to talk to you about all these networks and related to all those things. So how to unshare, stop presenting. Okay, I am back. Any questions, please?
Thank you, sir, for accepting our invitation and for your valuable talk. So, once again, thank you, sir.
Dr. Divyendu, thank
Yes,
you.
yes, sir. Yes, sir. Thank you, sir.
So nice of you.
Sir, I have one question.
Please go
So,
ahead.
so I see a lot of talks going on 5G as compared to Wi-Fi. So,
Yes,
what will be the future of the relation between these two, the 5G network and the
they,
Wi-Fi?
they, they will coexist. I'll tell you why. For certain number of years, from now to say 5 years or 6 years, both will coexist. But there is a possibility if 5G gets a unlicensed spectrum. Do you know unlicensed spectrum? I
No,
will tell
sir.
you what is unlicensed spectrum. I'll tell you. Please listen. There is a something called ISM band. I for industry, S for science, M for medical. ISM band. That band means the frequency bands, not your music band. Okay. So I forgot that band. You people know better than me because I have two kids now. I have they talk about a lot of bands. Okay, music bands. So this is frequency bands called spectrum. So these spectrums actually, this ISM band is signed by all the 190 countries across the globe under the United Nations that this ISM band will not be auctioned, not be sold. Government cannot sell it. It is free. Wi-Fi belongs to that band. It's a free. So as a result of which, if we put a Wi-Fi anywhere, we do not pay money for the spectrum. But when you use 4G or 3G or in future 5G, you have to pay money for the spectrum, and spectrum is very, very costly. If you remember 4G auctions or 2G scams in India only, it is in lakhs of crores, not 1 to 10,000 crores or 30,000 crores. Across the country, lakhs of crores. 1 lakh has a 5 zeros, and then crores has 7 zeros. Okay, so like that. So coming to the point is 5G has not got this free spectrum yet. So So if sometimes the 5G will be allowed for speed spectrum, that there will be small cells, picocells they call it. Sorry, I'm drinking some coffee after a talk. Sorry. So, so if they use like that, then that you have to pay money. So if you look at your telephone bill, there is a no breakup so much. But part of the money what you pay to the Airtel, or I mean a big part of it, Airtel or Reliance or BSNL, the big part of chunks goes to the money they have already spent to buy that spectrum. For that only telephone bills are costly. India it is the cheapest, but the whole world is very costly. Other part of the world is very, very costly. So, so till that time, Wi-Fi will survive. But the moment a part of the band will open for the 5G and part paid, part unpaid, free, then this Wi-Fi will merge into the 5Gs because it will be easy to manage. But till that time, both will coexist and they will work together. Okay, Siddharth, that's a matter of concern, I know.
Yes, sir. Thank you, sir.
And very good question. I really appreciate that you thought deeply. I think you might be reading some review papers or maybe reading some things. Then these kind of questions comes to your mind because this is not a easy question for a first year, second year general. You must be reading. Good, good. Keep doing that and go move towards research R&D. Do higher studies. That's very important.
So I have another question.
Go ahead.
So,
Go.
so why do internet companies always provide, always promise a much higher data speed than what they actually provide to us?
Excellent question. Go and ask the companies. But yeah, let me tell you, there is something called marketing and grabbing a customer. After a customer comes in and paid the money, मैं उसको क्या खिलाऊंगा क्या दूंगा भगवान जाने. Only God knows. Only the company knows. That is the thing. Nothing else. They promise us a lot of things. That is the non-technical answer I gave, but as a truth. The technical answer is every system. I showed you those base stations, routers, everything. Every physical system has a maximum capacity. What they do, they connect more number of users with a minimum capacity, because more capacity means more money they have to spend. They don't want to spend money, so they want to make profit. Okay, so this is the two things. One is technical, other one is non-technical. So we are the innocent customers and innocent citizens who suffers a lot. It's a lack of integrity actually. Promising something and not giving. Very, very difficult thing here in some parts of the world. I told you, 4G research with all God's blessings, God's grace. I have done around 6, 7 years of research. I have a contribution to the standards of the worldwide accepted broadband 4G. But unfortunately, same 4G, but the reality, practically, same 4G I'm using when I come home from the office. 4 times, 3 times call drop happens within a few kilometers. So, but 4G research says if you drive in 350 kilometers per hour, 350 kilometers, there should not be any drop. Or at least 250, minus 100, 250. In cities, we cannot drive. In Bangalore, we cannot drive. If I'm elevated highway somewhere in the maximum 80, and inside the city 20 or 30. So reality system-wise, there is a problem, constraint. They overloaded the base stations, routers by number of customers. Because they more customers, they get more money with the minimum expenses. Ghosh Babu, समझ में आया?
Yes, sir. Thank you, sir. सर एक और सवाल है सर.
बोलो.
सर मैंने नोटिस किया है सर कि वाईफाई का स्पीड तो वेदर के ऊपर डिपेंडेंट नहीं होना चाहिए.
हाँ.
जब वेदर खराब होता है तो वाईफाई भी थोड़ा हिल जाता है.
हिल जाता है? कहाँ रे भाई? कहाँ हिल गया? तुम्हारा हॉस्टल में, ना घर में, ना रेलवे स्टेशन में, ना एयरपोर्ट में? कहाँ हिला है? यार वाईफाई होना नहीं चाहिए.
सर घर में ही सर.
घर में? मुझे थोड़ा सोचने दो. घर में वेदर खराब होने से भी हिल जाता है घर में, घर का अंदर?
यस सर. ऐसा होना नहीं चाहिए सर, लेकिन
नहीं रे बाबू, घर में माइक्रोवेव है क्या?
नो सर.
Microwave same frequency actually Wi-Fi, because this is, I told you na, IMS band. So industry band microwave also there. Do you have a cordless phone?
Yes sir.
Cordless phone frequency also same as Wi-Fi. So there must be a collisions of the packet.
Okay sir.
एंड घर का अंदर होना नहीं चाहिए, होता है कहाँ मैं बता रहा हूँ. तो if the Wi-Fi is there in your home and there is an airport close to you and there is a plane is taking off, there will be huge vibration in the air. Very close means I'm talking a few hundred meters away from your home. Aerial distance, I'm 200 meters from your home, airport, the strips, landing and takeoff. Those 2-3 minutes, the plane takeoffs or lands, those one, not 2-3 minutes, 1 minute say, whole vibration of the air happens. Then it happens. नहीं तो नहीं, बट वाईफाई में नहीं होना चाहिए. वाईफाई में इसी कंडीशन में, एक ही कंडीशन में होता है. और घर में माइक्रोवेव है, नहीं तो कॉर्डलेस फोन ऑन है, तब होता है. Or if your neighbors Wi-Fi frequency is matching with your frequency, then there will be a problem. Same frequency band. So while selecting frequency band, you can select should be different from your neighbors. Alok Divedi, go ahead.
Yes, sir. Sir, I have a general question.
Please, go ahead.
From country to country communication, we generally use fiber optic cables.
Yes.
And for that, we need to spread a lot of monies, and we also need maintenance. We also need to do maintenance time to time. But why we do not try to connect directly through the satellite?
Wonderful question. I will recollect my memory of class 11, 12. Okay. I'm long back. I graduated. You graduated recently. C is equal to F lambda. C is the speed of light, if I can say. F is equal to frequency. Lambda is the wavelength. Okay. And inside the fiber, the frequency F is equal to C by lambda. If C is the speed of light inside the fiber. So I have to divide speed of light in the vacuum, how much? 3 into 10 to the power 8 meter per second.
Yes, sir.
Divide by refractive index, 1.5 fibers. So 3 into, if I'm recollecting, I may be wrong, 30 years back. So 3 into 10 to the power 8 and divided by 1.5, and lambda is 1500 nanometers. Okay, to convert it into the meters. Okay, so if you do it, the frequency will be very high. So that frequency means I can carry very high bandwidth inside a fiber per lambda. 1 lambda means wavelength. So red light is a 1 wavelength, green light is a 1 wavelength, blue light is a 1 separate wavelength. So if I pump in 1 red light, 1 green light, 1 blue light inside a fiber, each one will carry my high bit rates. I mean, 1 wavelength can carry now 100 gigabits now. In satellite, I cannot have such a high bit rate transmissions. Wireless satellite is far away, 20,000 kilometers or maybe 10,000 kilometers. Just find it out. Geosynchronous satellite, far away. So I cannot transmit such a high bit rate from Earth to the satellite, and satellite has to transmit to the other side of the. I'll call you back, Guru, and next call. Take it's fine. So, satellite is not, but now people are trying through that SpaceX. Previously, you Google it, there was a Motorola company, which is now not there, Motorola network. Now, on one part of, they tried it first, making a satellite networks over the Earth for internet, but they failed, miserably failed. And for that only Motorola collapsed. They pumped in so much money. But now SpaceX is trying. But beating fiber is difficult, high bit rate. Sorry, I explained you from classic fundamentals of physics to the fibers carrying capacity, to the satellite carrying bit rates, to the why. And backbone, I need huge traffic. For an example, whole country's transmission happening here to US. Can you imagine so many transmission happening both the sides? Bitrate is in few hundreds of gigabytes per second, multiple hundreds or thousands. Got it?
Yes, sir, got it.
And so, adding to Devan's question, like, why is there no regulations on the commitments provided by the mobile network providers? Like,
Sorry, which regulation you are talking about?
like, so when they commit that, they will say give some specific
Who said
speed
you there is no
on.
regulations? Who said you there is? But you have to go to the consumer court. We made a case against them, fight against them, give them the proof that they have not given you this bandwidth. It is who has time? We cannot prove them like that. They will beg apology. They shamelessly beg the apology. Period. Then the judge will say, "छोड़ दो इनको इस बार next time करेगा तो फिर next time will run after the case." Honesty is very important. For that only, you people are our future of our country. As much as possible, now people are cleaning it up. As much as I'll not tell, but a lot of cleaning is happening now in the system. A lot of cleaning happening. You cannot imagine, silently happening. We are the technologies people are helping. Technology people has a great role to play. You people are the future. You're bright and country is in your hand. By using technology, you clean it up. Some simple example I'll give you. Previously, if you go for a birth certificate or a death certificate, I'm giving the two extreme of a human being. Either he is born, he's dead. And you go and stand in front of the municipality office for that certificate and pay them $500 minimum. Not all the people ask for money, but the most of the people. But now, everything is online. Birth certificate, hospital will send the name, it is in the database. You just give a code which is given to you by the hospital. Birth certificate with the seal, everything will come to your email or your system. Download by paying 5 rupees. Period. I just give you birth to death. In between, so many things happens. I don't want to say that. So, silently somebody invented that as a technology, an application. And infrastructure network is there, database is there. So somebody is working on network, somebody is working on application, somebody working on security, somebody working on database, somebody working on all kind of things. It's solved. So you imagine like that, what can I do? So country is waiting for you. Work hard. There's no, and take care of your health and be positive always. Always think that what I can do for the others. Never think about yourself. You will be a great man one day if you are hardworking. Nobody can stop you. So, but if you think too much of yourself, you will be always in tension. Hey, mera kya hoga kal? You do simply hard work, nothing to worry. Tomorrow will bring everything to you. But always think about others. I have so much poverty in my country, I have so many things, my friend. We all, in our student life, we know we all struggle. I don't know about you, but our time, only cycle. And foods in the hostel was not good. But nowadays, it has improved a lot. I don't know, I'll come if I get a chance to Shillong NIT. But food has improved a lot. So a lot of things has improved. Enjoy that and study. Play well. Every day, play 1 hour. Playing teaches us 3 things. 1, team spirit. How jointly play as a friend in a football or a cricket match. As a team spirit. Team, how to. Second, teaches one thing so nicely, many of us don't discuss. You see, today you're playing a badminton or TT. You win the match or you lose the match. If you win, you go and things happy and things that what shots you play and what to improve. If you lose the match also, you don't feel so unhappy. Okay, fine, I lose. So there in life, there are many times we may fail in our life. So this team Playing teaches us that how to gracefully absorb winning and losing. Third thing is that physical fitness. It keeps your brain health fresh to do really hard work. Play every day with a good spirit, and you'll learn a lot. Team spirit and and also the failure and success in our life in the schools. Nobody teaches us failure. Every time parents say success, success, success. 98% you have to keep in class 10, and I don't know if something above 100% also parents will say that. So this happens. Now I was a student, now I'm a parent, so I know. So thank you again. So wonderful questions from your side, and thanks to Dr. Dibendus, thanks
So
to
one
Professor
last question, sir.
Harish. Any other questions you have?
Yes, sir. Coming back to the 707 billion problem, sir. So what
Bola,
exactly,
bola.
sir, what exactly do we need to solve it? Like, do we need to increase the number of servers or the...
Everything. For first of all, you have to solve the network protocols challenges, which I showed you. Because so many devices wants different performances. Some wants 1 millisecond to 2 millisecond of delay, someone wants 1000 so our protocol stacks will change completely. That is one. I need lot of servers and database to store the data from coming from these 707 billions of devices. Okay, and these IoT devices have to be invented, new IoT devices. So kind of things. So a lot of research problems are there, R&D problems are there. Gosh. So now I see the Sunny has come up, so that means I have to close my
No,
discussion.
sir. No,
Thank
sir.
you.
Just to have a small screenshot, like to capture this moment. So
Sure.
I would like to ask everyone to please switch on your cameras so that we can capture this moment.
Then Nikshita,
Yeah.
I capture.
Uh, Thank you, sir, for enlightening us with your knowledge. Today's lecture was full of knowledge and interesting things. It gave us deep insights, and also it really revealed so many interesting facts for us. Thank you so much for taking out time from your busy schedule, sir. Like I'm pretty sure every one of us are like we have got the precious knowledge which will definitely help us in our studies and future. Thank you once again so much, sir.
Thanks, Leslie, and thanks to all of you giving me an opportunity to talk
Thank
to
you, sir.
you. Have a wonderful life and wonderful
Thank you,
career.
sir.
Namaste.
Yes, sir.
Namaste.
Yes, sir. Thank you, sir.
Thank you, sir.
I'm logging off there, Sini.
Yes, sir. Thank you.